Okay, so for completing the square, we want to make this expression 1x squared plus bx into a perfect square. Add b over 2 quantity, so in parentheses, the parentheses are necessary here, b over 2 quantity squared. So this is saying if you have an expression in this form and you want it to turn into a perfect square, meaning something squared, then what you need to add is this exact expression. So you'll start with something that looks like this, and it will always end up, and you'll add b over 2 squared to it. That, once you add that on, will always turn out to equal x plus the b over 2 all squared. So it turns this expression into something squared. So that is the idea behind completing the square. So let's apply that technique. So this one, again, we're back to find the zeros. So remember what that means. If you want to find the zeros of a function, then you take that function and set it equal to 0. So this one, if I see this, the first thing I do is, can I ask myself if I can solve it directly, get the x by itself. But this one's a little bit too complicated to do that. And the next, I would probably try to factor it. I would have to come up with two numbers that multiply, and this one a is not 1, so you'd have to do the AC method. So you'd have to do 4 times 13, which is 52. So you'd need to think of two numbers that multiply to 52 and sum to negative 16. So that may or may not work, but in any case, we would, that if you could find two numbers, then you can do it that way. But for this technique, we're going to do completing the square. But in order to do completing the square, you have to have it in this form that was talked about above. It must be in this form first before you can start completing the square. So we have a little bit of that going on, something x squared plus bx. But we don't want this part. So what I'm going to do is subtract that over. So it's a good idea to really just have that equal some number on the other side if you're dealing with an equation. So I'm going to move that over. And now it's almost in that form, except a has to be 1 when you complete the square. Here, what is a? A is 4. So we need to force it to be a 1 somehow. So what I'm going to do is to turn that 4 into a 1, I'm going to divide both sides of the equation by 4. And I'll get that. Make sure you divide every term by that number. So 4 divided by 4 is 1, negative 16 divided by 4 is negative 4, and negative 13 divided by 4, just write like that. Okay, now we are in the 1x squared plus bx equals a number form. Now, at this point, we can complete this square. So the rule says that if we want to do this, we need to add b over 2 quantity squared. So over to the side, I'm going to write what b is. So at this part in our solution, what is b equal to? It's equal to negative 4. And then I'm going to write b over 2. So if b is negative 4, what's b over 2? Well, that's going to be negative 2. Negative 4 over 2 is negative 2. And then I'm going to take that whole thing and square it. Well, if you take negative 2 in parentheses and square it, you're going to get 4. So this is what we need to add to this expression. So x squared minus 4x plus 4 equals. Well, if I add a 4 to this side of the equation, I have to add it to the other side of the equation to keep the expressions equal to each other. And then the point of adding that 4 in is that this will always become a perfect square. That's why it's called completing the square, because it turns this expression into a square. And according to the rule, it will always equal x plus b over 2 squared. So the number that we put here has to be b over 2. So you go back and look on this side. b over 2 was minus 2. So we have minus 2 here. Equals, and then we just need to add these fractions together. 4 is 16 over 4. So negative 13 over 4 plus 16 over 4 is 3 over 4, if you add those two together. Now, we are back to an equation that we can solve what I call directly. Let's get rid, we're trying to get the x by itself, so at this point, let's get rid of the square by taking the square root of both sides. And so we'll have to put plus and minus root 3 over 4. And then we simplify this if possible. Well, this is root 3 over root 4. So on top I have root 3. And on the bottom, root 4 is the number 2. And then lastly, I'm going to add the 2, and just like earlier, I'm going to put the 2 right here in front of the plus and minus. So those would be our two solutions. 2 plus root 3 over 2, and 2 minus root 3 over 2. And in fact, in this case, these would be zeros. So if you plug 2 plus root 3 over 2 in here, it will make this expression equal 0. Or if you graphed it, these two values would be the x-intercepts. Alright, let's do another one. So again, the technique we're trying to use here is completing the square. But, like we've done often in the past, the first thing we look for is a greatest common factor. Well, all of these are divisible by 7. So before I start, I'm going to factor out a 7. And now that 7 is just a constant number, so we can divide everything by 7. We divide this side by 7, they cancel. 0 divided by 7 is 0. So by doing that, it made our numbers nicer because they're smaller numbers now. And we're trying to complete the square. So again, our goal is that we want it to get in the form 1x squared plus bx equals the numbers. Well, we do have a 1, that's good, but we need to move that 2 over. So I'll subtract 2, and now we're ready to complete this square, because we have 1x squared plus bx equals the numbers on the other side. So again, at this point, completing the square, I'm going to write what b equals. So what's b this time? B is 8, and then I'm going to write what b over 2 is. Well, 8 over 2 is 4. And then we take that, square it, I'm going to get 16. So this is the number that we add in here. But, just like last time, if you add something to this side of the equation, you must also, of course, add it to that side of the equation as well. The point of doing that is that this expression will always turn out to be something squared. And put the variable there, x. And then what goes in here is b over 2. So what was b over 2? b was 8, b over 2 is 4. And it's a positive 4. So you have to write plus 4 equals, this is what? Negative 2 plus 16, which is 14. And now we're trying to get x by itself. Let's get rid of that square. take this square root of both sides, and then so we have to put plus and minus. That root cannot be simplified, so we just subtract the 4, put that out in front of the plus and minus, and we have our two solutions. Alright, so that was the completing the square technique. The last technique that we'll talk about is using the quadratic formula. This is nice because it's just one direct formula where you just plug in the numbers, simplify, and you have your solution. So for this technique, you just need to make sure that the quadratic equation equals 0. You have ax squared plus bx plus c equals 0. A is not 0. Then if you have an equation like that, then the solutions will be in this form. X equals negative b plus and minus the square root of b squared minus 4ac all over, and this fraction is one big fraction, all over 2a. So you need to have this formula memorized. So if we're trying to use this technique, the quadratic formula, that means we need to have it equal 0. So the first thing I'm going to do is subtract the 6x from both sides. And I put the 6x, the minus 6x in the middle because that's what the form should be. Ax squared plus bx plus c equals 0. So I'm writing it in the correct form, and then I'll identify what a and b and c are. So what's a? A is 1. What about b? Negative 6. And c is negative 1. So for this technique, all we do is write down the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And we just plug the numbers in carefully. Minus b, well, b is negative 6, so negative b is positive 6 plus or minus the square root. B squared, so that's negative 6 quantity in parentheses squared, which is 36, minus 4 times 1 times negative 1. 4 times a times c, all over 2 times 1. And then the rest just simplifying that expression. So inside the parentheses, inside the root, 4 times 1 times negative 1, that's negative 4. So we have 36 minus negative 4, which is 36 plus 4, all over 2 times 1, which is 2. Okay. So that leads us to 6 plus and minus root 40, all over 2. And then we should simplify the root if possible, and we can, because 40 is equal to 4 times 10, so we can pull out the root 4, which is 2, and we'll leave the root 10 inside, all over 2. And then we can kind of split this apart if we want. I can say that we have 6 over 2, which is 3, plus and minus 2 root 10 over 2. If we do 2 root 10 over 2, the 2's cancel, and we're left with the root 10. So here would be our two solutions, 3 plus root 10 and 3 minus root 10. Next, let's use, we are trying to find the zeros once again of this. Well, that means we set it equal to 0. So again, I would try, if I see this this quadratic, I think, can I solve it directly? But it's, when you have these multiple x's, that's not going to work. And then I move on to factoring. Well, what would be two numbers that multiply to 5, positive 5, and they sum to positive 4? There aren't any that you can think of that will do that. So factoring wouldn't work here. So then you move on to either completing the square or quadratic formula. Pretty much Either is fine, but in this case we're practicing the quadratic formula. So let's go ahead and do that. Find what A, B, and C are. So what's A? A is 1, B is 4, and C is 5. So quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Plug all the numbers in. Minus b would be minus 4 plus and minus the square root. B squared is 16 minus 4 times a times c. 4 times 1 times 5 all over 2 times a, which is 1. Then we get minus 4 plus and minus square root. We have 16 minus 20. 4 times 1 times 5 is 20 all over 2. So what's 16 minus 20? That's negative 4. Well, earlier on in the class this was not okay, but if we're finding the solutions, we've discussed complex numbers, so we can write the square root of a negative as a complex number. So remember from the last section, the square root of negative 1 is I, and then we also have the square root of 4, so this whole thing is just going to become 2i. And then we divide by 2. Well, everything's already divisible by 2, so we can just write that x equals negative 4 over 2, which is negative 2, plus and minus 2 over 2i. Well, 2i over 2. 2's cancel, we just get I. So we have imaginary or complex solutions this time. And that's okay. So sometimes when you're doing any of these techniques, that might happen. You might end up with i's in your solutions. Okay, so that's the quadratic formula. And now that last one leads us to the concept of the discriminant. So the reason why we got I is because this inside part was negative. Well, what's the inside part? Where did that come from? That came from b squared minus 4ac. So this inside part has a special name. It's called the discriminant. D equals b squared minus 4ac in the quadratic formula is called the discriminant. And of course, that's just a number. So that number can be bigger than 0, or it could equal 0, or it could be less than 0. Well, if it's less than 0, like in our last example, we had imaginary solutions, and you're going to have plus. Remember, in the quadratic formula, we have plus and minus, so you're going to have plus one of those and minus one of those imaginary solutions. So we'd have two imaginary solutions. And then if it had turned out to be bigger than 0, well then maybe that would be root 9, which is 3. But then we have plus the 3 and minus the 3, so that would have two solutions, and they would both be real. And then if that number inside the square root, the b squared minus 4ac, if that is actually equal to 0, well then the square root of 0 is just 0, and adding it or subtracting it isn't going to give you two different numbers, it'll just give you the same number. So in that case, you'll have one real solution. So sometimes all we care about is how many solutions are there going to be, and are they going to be real or imaginary? And that's where the discriminant comes into play. So this next example asks, how many real solutions does this equation have? Well, first of all, you say, okay, this is a quadratic, so let's find the discriminant to answer this question. So let's write, though, what A, B, and C are. What's A? A is a third. B is negative 2, and C is positive 4. So the discriminant is b squared minus 4ac. Well, b is negative 2 squared, so put that in parentheses. Anytime you do the b squared, parentheses squared, minus 4 times a times c. So we get that this number is 4 minus 4 times 1 times 4 is 16 on top over 3. And then 4 is 12 over 3 minus 16 over 3. 12 thirds minus 16 thirds is minus 4 thirds. And then all we actually care about, though, is which category does it fall into? Is it bigger than 0, equal to 0, or less than 0? Well, this turned out to be less than 0. Therefore, it's going to have 0 real solutions. If we're answering the question, it asked how many real solutions. No real solutions, because it's going to have 2 imaginary solutions. So that's the discriminant. And now let's do another type of example. We're given a graph. It says use the graph shown to find the x-intercepts of the function and the zeros. Okay, well, the x-intercepts are right here and here. So the x-intercepts are the points 1, 0 and 3, 0. Done. What are the zeros of the function? Well, we already talked about the zeros of the functions are basically the x-intercepts. So the zeros would occur at x equals 1 and x equals 3. It's just the x-coordinates of the x-intercept. And so that's all we would do for that problem. Okay, so now this is the last part of this section, 3.2. This is the last one, application problem. So say a ball is dropped from a height h0 above the ground. So you have a ball and you're at that height when you drop it. The height after t seconds is then given by this equation, h equals negative 16 t squared plus h0. Again, h0's just saying that's where you dropped it from. And then h is going to be measured in feet, however many feet the height is after t seconds. If the ball is dropped from the top of a 288-foot building, how high off the ground is the ball after 3.5 seconds? So I would start filling in the variables, like what is this representing? It's asking how high, so what variable is that? What about that 3.5? Well, that one is pretty obvious. That's obviously the time, 3 seconds, 3.5 seconds. And then it's asking how high is the ball going to be? Well, that's what the whole point of this function is. It says the height is given by that equation. So height is h. So what's this 288? That's where you're dropping the ball from. So that's the h0, the height that it's being dropped from above the ground. So now we can write this, plug in the numbers. We don't know h. T is 3.5 squared plus h0 we said was 288. Now you can do 3.5 squared by hand, but actually I'm just going to change that. That's 7 halves. It's going to make it easier because it's easier to square 7 halves, because 7 halves squared is 49 over 4, right? 7 squared over 2 squared is 49 fourths. And this makes it multiplying easier because I have a 16 on top and a 4 in the bottom when I'm multiplying these. So 16 divided by 4 is negative 4 times the 49 plus 288. Negative 4 times 4, or sorry, negative 4 times 49 turns out to be negative 196 plus 288, and that will give us a height overall of 92 feet. So what this is saying is if you drop this ball from a 288-foot building and you wait 3.5 seconds, then it will be 92 feet off the ground at that point. Okay. How about if the ball is dropped from the top of a 288-foot building? Okay, so we still have our same h0. Now it's asking how long will it take, so with this time we don't know time, for the ball to hit the ground. Well, if it's hitting the ground, we know h0, we don't know t. What would h be at the ground? Well, it's hitting the ground, that means the height is 0. Right? So we can write down the original equation again, plug everything in. Height is 0 because it's hitting the ground. Minus 16, we do not know t squared, plus h0 is 288. And now this is really similar to the equations that we've been working with in this section. It's a quadratic and it equals 0. So you can use the multiple techniques we've discussed. But again, I always try to do it directly first, which is, can we just get that t by itself? Well, if I add the 16t squared over, I get that. And then I could just divide both sides by 16. 288 divided by 16 is actually 18. And then to get rid of the square, I'm going to take the square root of both sides. So I get plus and minus root 18. Well, 18 is 9 times 2, so I have plus and minus 3 root 2. But of course, this is time, so it can't be negative. So time is 3 root 2 seconds. But of course, we would never say that it takes 3 root 2 seconds. If this were, you know, a test question, though, you could just leave it like that. Or maybe if you're doing online homework, then you could use a calculator and see what this comes out to be. This is going to come out to be approximately 4.24 seconds. So, what this problem's saying is if you drop the ball from 288 feet, it will take about 4.25 seconds before it hits the ground. Okay, so that is the end of the section 3.2 notes.